right, so I am resuming with this video after a little bit of a break. So we're in the middle of this supply and demand example, and we saw that if the price is $10, then there is more demand than supply. So there will be theoretically 300,000 people who want to buy this widget who will not be able to because there aren't enough people who want to sell it to. So in part B, we're going to be looking at the graphs. So what I'm going to do is I'm going to add add a page to my document. So plus page is here in blue, so control document. And let's add a graphs page. And keep in mind, if the pages are in the same document, they can interact with each other. So I want to graph these two functions, which were my supply function and my demand function. And they are already stored in the calculator. We used control equals to teach these to the calculator. So if I go to variables here, I can just put D for demand, and I have to call the variable X when I'm graphing. We'll make sense of that graph in a second. And then I can also graph, So what else am I graphing? I want to graph another function. But for F2, I can say, all right, for F2, I want to graph my supply function. Functions that have been given names and have been taught to the calculator are stored here. So demand and supply are there on the calculator using the formulas that we taught it back on that calculator page. You can just click these to go from one page to the other. Now we want to set a window that makes sense. So we go to menu, window zoom. Number one is window settings, X. X here corresponded to price. It's going to be at least 0. And what we saw before is that at a price of 10, that seemed too low. Right? It was too low to get enough people to want to sell these things. So let's make this substantially bigger. It's not clear how much bigger we should make it. I'm just going to say 100 to be safe. We can change it later if we want to. What's Y measuring? Y is measuring the number of widgets that will be bought or sold. That should start at 0. And what we saw before is we were looking at numbers like 400 and 700. So we want something fairly big here. I'm just going to go 1,000. These numbers might be a little too big, but too big is better than too small. So I'm thinking of all the possibilities of prices between 0 and 100, and quantities between 0 and what's really a million, because we're counting in thousands. So here's my graph. So with this graph, I see my intersection. So I'm going to copy this onto my screen. X here represents the price per widget. Widgets are just these fake items that we use in supply and demand examples and other econ and business examples. It's fake, so we can say whatever we want, right? One day a widget can be worth $8, the next day a widget can be worth $35, and it all makes sense because we're just making this up. And then Y here is measuring the quantity bought or sold, or at least the quantity in supply or demand. It's measuring how many widgets in thousands. So my supply graph looks like this. That one's a line. My demand graph looks like this. That one's a curve. And there's an intersection. So menu, analyze graph. Number 4 is intersection. Click left, click right, and it finds that intersection for me. So 16.51 and 660.6. So let's think, what does that mean? When these intersect, it means the price is the same and these quantities are the same. The quantity, basically the supply quantity and the demand quantity are the same. The number of widgets people want to sell is the same as the number of widgets that people want to buy. So if the price is, X here is really price, $16.51 per widget, then supply and demand will be equal. And the number is, this is in thousands, 660,600. So 660,600 widgets, that's the quantity, would be bought and sold. Producers would want to sell that many, consumers would want to buy that many. And in theory, this is the scenario where people are happy, right? There aren't people who really want to buy it and can't. There aren't people who really want to sell it and can't. This is what's sometimes called an equilibrium price. So in theory, in a market economy where people are allowed to change prices and readjust, prices will nudge their way towards this equilibrium, right? If it feels like a price is too low and there are all these buyers who are unsatisfied, then then basically the price will inch up a little bit, and therefore more people will be willing to sell, but fewer people will be willing to buy. If the price is too high, it can inch back a little bit. So this is in theory. It doesn't work perfectly in real life, but in our economic system, generally speaking, people can choose whether or not to buy things, and stores can readjust prices to adjust, if they're selling too many or too few. So things will tend towards this equilibrium, at least in theory. Okay, one more example. We have this function here, and there was a typo, that tells us temperature in terms of hours since midnight. And I want to know, when will the temperature be exactly 88? So this one's a little different because I'm not giving you two things. But let's graph this and try to make sense of it. So I'm going to just start a new document. And let's put a graph on here. So I'll graph this function, and it is 12 sine of 15, I have to call it x to graph it, minus 100 plus 80. Now, whenever you're doing anything with trig, pay attention to your mode. I'm telling you that for this one, you want to be in degree mode. On your screen in the upper right, mine says degree, D-E-G. If I click it, it goes into radian mode. If I click it again, it goes into degree mode. So you can switch back and forth. And unfortunately, it appears as though clicking that wipes out the formula, maybe because they want a safeguard where if you did the formula in degrees and changed to radians, they don't want you to even carry that over. So I'm checking I'm in degrees, and I'll do this again. Sine, just FYI, if you want to get sine on the calculator, next to the 7, it says trig. So if I click there, I have all my different trig functions. So 15x minus 100 plus 80. Okay, what window makes sense here? So time here is measuring hours, x is measuring time in hours since midnight. So temperature fluctuates over the course of a 24-hour period. So if I go to my window menu, x is basically time. A full day would be 24 hours. Y is measuring the temperature. Just out of habit, let's leave that at 0. And we're told this is temperature in the summer. So we're talking about pretty hot temperatures. Let's go 110. So I'm looking at what's happening over a 24-hour period with temperatures ranging from 0 to 110. In a case like this, you could make that minimum a lot higher, right? Maybe like 60, right? It's summer, probably it stays at least 60. And here's my graph. So right here, 0 is midnight, kind of cool. And then over the course of the morning, warms up, warm in the early afternoon, cools down, and it gets back to where it was before. So I want to know, when is the temperature exactly 88? So I want to be able to see a height of 88 on this graph. So, what I can do, so if you want to play around with a graph, if you go to menu, one of your options is trace. You can trace the graph, and that just lets you put a point on the graph, and you can move it with your arrow keys, just to kind of explore different coordinates. This is just a rough estimate. So 5.7 hours after midnight, the temperature is 77 degrees. Move it around. 7.2 hours after midnight, the temperature is 81.67 degrees, etc. I could get a rough estimate by just tracing, which isn't bad. That's a good use of technology, but we can probably get this more accurate. So what we've been doing so far is we've been talking about intersections. So the trick is we need to draw in 88. When is the height of this graph 88? So the trick is we're going to draw a horizontal line so we can see it as an intersection. So I'm going to graph another function, and I'll graph the extremely boring function that's just always equal to 88. That doesn't seem very interesting, but what it does is it draws a horizontal line on the graph that lets us visualize a height of 88. So I'm going to draw my graph here. So this is measuring time. This is measuring temperature. F looks kind of like so. When you graph a sine function, you get wavy stuff like this. And then we just drew in a horizontal line at a height of 88. This is basically y equals 88. And we can see there are two intersections. Those would correspond to places on the graph where height, which is temperature, is 88. So there are two occasions over the course of the day where the temperature is 88. And the calculator can find these. So menu, analyze, intersection, lower bound, upper bound. So it finds one of these. The x coordinate here is 9.454. The y coordinate obviously is 88. Let's find the other one. Oops, analyze graph, intersection, a little bit to the left, a little bit to the right, click. The other one happens when x is 15.88 and y is 88. So what is this telling us? It's telling us that the temperature is 88 at these times. But let's really try to make sense of this. When I say at what time of day, right, we don't talk about time in decimals. So let's see if we really understand this. This is saying 9.454 hours since midnight. So the 9 is 9 hours. And then we have 0.454 hours. And what we could do is we could say, oh, well, there are 60 minutes per hour. So I'm going to add a calculator screen here. And I can take that 0.454 that was left over and multiply that by 60 to get a sense of how many minutes that is. That's about 27 minutes. We can round this a little bit. So when I say 9.454, that means 9 hours and 27 minutes since midnight. We would call that 9:27 a.m. What's this other time? Well, that would be 15 hours. And then the 0.88 hours, again, let's convert that to minutes. There's 60 minutes per hour. So 0.88 times 60, with a little bit of rounding, is about 53 minutes. So 15 hours and 53 minutes after midnight. Well, the 15 is really 12 plus 3. So 12 hours to noon plus 3 is 3:53 p.m. So whenever possible, you want to give answers that actually sound like a human, right? If the question sounds like something a human would say, at which time of the day is the temperature 88 degrees? You don't want to give some mechanical super mathy answer like, oh, x equals 9.454. That doesn't really answer this question. If I say hey, at what time are you going to come to my party? And you say, oh, I'll be there at x equals 18.731. You sound like a total weirdo. So in word problems, really try to give an answer that reflects how we would talk about it in this circumstance. And sometimes that means a little bit of extra work because we have this weird time system that's sort of base 60. You have to convert the hours to minutes. All right, so that's it for these videos. Hopefully this helped you out if you got stuck on anything. And if you're not comfortable with the calculator steps, watch what I did and think about how to click on different things. Okay, that